Hello YouTube, thought I'd do a quick video here. If you've been following my channel, you know that I use a mini PC now that I plug my interface board into here, and my interface board hooks up to the Retevis RT97S or the Midland MXR10 GMRS two-array repeaters. That lets me get the repeater online. I'll post a link in the description below on my interface board if you're interested in that. But that lets me get my repeaters online so I can run date and time announcements, weather announcements, Zello, repeater ID. I can plug my interface board into this little mini computer and I can have all that for my repeater. Now, I did a video about this. The one thing one issue this has is that when power goes off and comes back on, it does not boot up by itself. You have to physically press the power button. Now, it may not be a big deal if this is in your house or it's right down the street, but this can be a problem if you have your repeater set up elsewhere and you don't want to drive there to press the power button to get this thing to boot up. Or maybe you just don't want this PC to turn off no matter what. Maybe you just don't want that for whatever reason. I have designed and maybe building, and I may have for sale, a backup circuit that will let you hook it up, plug and play type of setup, that will let you hook it up to a battery that will keep this thing running during a power failure, and as the power comes back on, this thing won't even miss a beat. Okay? Now, you can use this circuit even if you're not even going to hook up a repeater to this. You just want the mini PC or Raspberry Pi or whatever device you have. You don't want it to turn off when the power fails and comes back on. Whatever device you have, this circuit you can hook up to it. I'm going to make it plug and play as best I can. Obviously, there's a lot of different plugs out there. That's going to be one of the things I got to figure out is the plugs, because there's not a standard on what size plug people or what size plug they use at the end of these adapters. But I'm going to try my best to make it plug and play as best as I can. I'm also going to have it be selectable with voltage. That lets you select from 5 volt to 12 volt because not every device you have is going to be a 12 volt. Now, I know there are some types of battery backup circuitry, but the ones I've seen use a relay, and if you read the fine print, there may be a second delay, and that might be enough delay to make this thing shut off. I do not know. I do not have that circuit here to test it. Maybe it works fine. I don't know. But I designed a circuit that will not have absolutely no delay at all. I'll show that proof here in a minute. Works great. And on top of it, my circuit will be selectable voltage. So even if you don't need this because you run a battery, you run your repeater on solar power, and you run a battery anyways, and you don't need this switchability that this can do, mine circuit will still let you hook it up to your battery and select 5 volts or 12 volts output without using an inverter. Okay, so I'm going to have that function in my circuit on top of it. On top of no delay, no relay, voltage selectable. It's what I'm planning on doing. Okay, so now also too, I like to mention my circuit is only meant to do small devices like a mini PC or a Raspberry Pi. It's not designed to do a whole repeater system for battery backup. Could I design one that could do that? Maybe in the future I'll come up with something for that. But for this circuit, it's only meant for small devices. This circuit, it will be designed to handle up to 3 amps. Okay? So it'll be plug and play, meaning as best I can, you plug in the wall wart, and then you hook up your battery, your 12 volt battery. Now the good news is if you just need to power your mini PC or your Raspberry Pi, you don't need a big 12-volt battery. You can use one of those ones on that alarm panels, alarm system use for their battery backup. You can get a small one. If it's, just a temporary, you're not running it on batteries for hours and days. It's just temporary until the power gets restored. So you don't need a big battery if that's what you need. Whether it's Raspberry Pi or whether it's a mini PC. Raspberry Pi will boot up by itself, but maybe you don't want it to even turn off. It can be any device you don't want it to turn off that's 3 amps DC only. Now if you don't know, look at your wall adapter. There should be an ID tag on there. Look on there and it will tell you how many amps and what's the voltage. Obviously these wall adapters, they rate them a little bit more than what the device actually draws, but that's okay. But look on there, and if you're interested in this type of circuit, shoot me an email. I'll post an email link down below. And if you don't really understand this tag, take a picture of it and send it to me in the email, and I can tell you, hey, yeah, yours would work for this. Like I said, this will be for either 5-volt or 12-volt output selected. This will not charge the battery. I'm not going to go down that path because to charge a battery properly, you got to know what type of battery it is. You got to monitor the voltages. You got to monitor this and that. I'm not going to do that. You can buy trickle chargers cheap nowadays that you can hook to your battery to keep your battery charged up. This circuit will not charge a battery. Just to be clear on that. I'm not, like I said, I'm not going to go down that path. It's not worth it where all the other chargers are out there. But again, this is meant for small devices, like I said. So, and what I have here is a circuit, which you can't see. There is a circuit underneath there. This ain't just wires hooked up, by the way. But there's no relay that I use. There's no delay, and it will be adjustable voltage output for your device. But for now, in this video, I have it set to 12 volts. I have it hooked up. It's be plug and play when it's all said and done. That's the plan. So what I have here is I have the AC plugged into here, right here. And then I have a 12-volt battery, which you cannot see, hooked up to here. So what we're going to do, here is the screen of the mini PC, right here. Now I'm going to show you there's absolutely no delay. There's no flicker. There is nothing. Okay, watch this. Let's unhook the AC adapter. The power went out. Power failed. Storm came through. Power turns back on. Now we're back on. No flicker. Not even a flicker. Let's go the other way, just for whatever reason. Unhook the battery. Battery went dead or got disconnected, whatever. That's proving that this is running on power now. This is running on the wall adapter. Let's hook the battery back up. Get that back on there better. Now we're going to hook the AC adapter. Now it's just running on battery. No flicker. Didn't even miss a beat. Now it's to prove to you that I'm on battery. I'm going to unhook this. Since we're unplugged from AC, this thing will shut off. So let's say your battery went dead for whatever reason, or Johnny come walking over and he trips on the cord and he unplugs the battery. There you go. So there you have it. So this circuit absolutely has no delay whatsoever. It works really good. I'm doing some testing as we speak. But if you're interested in this type of circuit, and again, you can use this just for the PC itself. You don't need to hook up, repeaters and stuff to it. Let's say you're just a general person that doesn't want their PC to go dead because you're running a server, or you're running, some type of device that you got plugged in here. Or maybe you're just running a server on this thing, or any mini PC that, as long as it can, in this design, it'll be 3 amps max. So as long as it's within the 3 amps limit and either 5 or 12 volt, this backup circuit will work. You got to get your own battery, but this backup circuit will work. So there you have it. Any comments or questions, please post them down below. Please subscribe. Thank you and have a good day.